Hi, welcome back.
Morning.
Morning. Hello. So we've spent a couple of days already talking about set notation and different types of numbers and the different classifications of them. Now we're going to step back for a second and go into something that hopefully feels very like you've already done this before and very much review. And that is the graphing of linear functions. We're going to start off with the table. Take a look at this table here. This is the function. It's read f of x. It's not a multiplication. We're not multiplying whatever the value of f is to x. What we're saying with this notation is that I have some sort of machine and his name is f. And when I stick x into the machine, I do this to it and it spits out a number. Okay? So f of x equals, and then this is the thing that I'm going to do to x. In this case, I'm adding 3 to it. Now this y here is the same as f of x, so the y value is the f of x value that comes out. And if I take a look here, here was my x value. In here I rewrote the function rule. Everywhere I have an x, I replaced it with -5. And then I did my rule -5 plus 3, and it gave me a result of -2. And the rest of the table is populated that way. Okay? Let's remind ourselves how we graph onto the Cartesian plane. So what I'm going to do is, I have to fold it so that way y'all can still see it. You guys don't have to fold your paper, you can just leave it as is. But because I have a limited amount of space, I have to give mine a little fold. Yep, now we can see everything. All right, so I need to graph -5, -2. So I'm going to start at the origin. I'm going to count to the left 5, 2, 4, 5, and then I'm going to count up 2. Down 2. 1, 2. All right, there's my first point. Going to continue graphing -3, 0. So I'm going to count over to the left 3, 1, 2, 3, and then I'm not moving up or down any. -1, +2, going to count to the left 1 and then up 2. The next one's 1, 4. I'm going to count to the right 1 and then up 4, 2, 4, and then 3, 6, 3, 2, 4, 6, and then 5, 8. So 5, then 2, 4, 6, 8. Who do we appreciate? We appreciate the fact that I have a random sheet of paper that I can use as a straight edge. You're welcome to use the daily work extra page that I gave you if you don't have a straight edge. I'm going to use that straight edge to draw the line, and then we can see how terrible I am at plotting points. We'll just pretend that's in the right spot. I clearly can't count, but here's the graph of the line of this function, and the function rule is f of x equals, take the value of x, add 3 to it, and that should live somewhere on that line. Easy enough? Good. Let's make it one step more complicated. Scooting down to the second example, I've got a table of values. My function rule isn't clearly stated, only part of it is. The problem is that we're missing that bit. But here's the good news. The good news is my table is populated with some values of x and y, and I can use that to draw the graph. Because once I have the picture, I'm able to read off the rise over run, the slope. And from there, I can fill in this, because that's part of my slope information. Okay? I'll show you how that happens here in a second. Let's plot the points that I have enough information to plot. So -10, -4, 2, 4, 6, 8, 10, 2, 4. And I plotted this one. I've got enough information to plot -6, -2, 2, 4, 6. So I did that one. I can't do the next 3, but I can do this one, 10, 6. So 2, 4, 6, 8, 10. 2, 4, 6. All right, and then I'm going to take my handy dandy line making tool. Hopefully I graphed these all. Yes, I did it right this time. Phew. All right, there it is. I can now read off my slope. So if I go from this point to this point, I'm going, rise 2 and run 4. Thank you. So the slope of this thing is 2 over 4, which reduces to 1/2. Now with it reducing to 1/2, this 1 would be here, and the 2 would be here. So my function rule is f of x equals 1 times x over 2 plus 1. Are we okay with how I got that?
No.
No. Okay. So let me scribble it down here a little bit. I had a slope of 1/2. Right? And so there's my function rule. Well, whenever I have this set up right here, I can think of it as 1/2 times x over 1. And then if I multiply straight across, 1 times x is x, 2 times 1 is 2, and so that becomes this piece right up here. Okay? All right. Now we have all the information, we can start filling in our table. So f of -10 equals -10 over 2 plus 1, then -2, so this is f of -2. All right. This one, I have a y value, but I don't know what x value creates it. So what I'm going to do is I'm going to go over to the graph, and I'm going to look at wherever y is 2. So scooting on over, looking at my graph, here is 2, and so here's where y is 2, and the x value of this is
2.
also 2. So then the x value here is 2, because we read that off our graph. Now there's a complete blank. That complete blank has an x value that lives somewhere between 2 and 10. You get to pick the number. What's the number?
7.
7. All right. I have 2 y values that are missing. I could go through and manually calculate them all. Or I can decide to be a little lazy and instead go to the graph and read where x is -2, y is 0, and where x is 7, 2, 4, 6, 7. It's, what number is that?
4.
That's 4? 1, 2, 3, 4. That's a little suspect to me. There could be an error in where I drew it, because 7 over 2 is what?
3.5.
3.5. And I'm adding 1 to that. So 3.5 plus 1 is 4.5. And my graph, my drawing reads 4. So you've got to be thinking, does that answer sound reasonable? And if it doesn't, you use a different method to try to get to a more reasonable answer. The biggest question is, well, how do I know when it's reasonable or not, right? Because that's really the hard question. Crunching the numbers is not so hard. So if I looked back here, I noticed that 7 over 2 wasn't going to be a whole number answer. It was going to be some sort of decimal or some sort of fraction. And so since my graph read some sort of whole number, and my rule looks like it's gonna give me some sort of fraction, my graph might have been incorrect. Because I did that manually, I drew it and I could have made a mistake. So I went in and I calculated it instead. Does that make sense? Feel better about when to decide whether it's reasonable or not? Good. All right, here's the last one. What does it look like the rule is? F of x equals x plus 1. Good. Let's populate our table. Thank you. I've got one where the x is missing. What's the x value for this one? -6, because that's what it says right here. Good. All right, let's go ahead and add 1 to everything. This one's done. -6 plus 1 is? -4 plus 1 is? Okay, and 2 plus 1 is? Good, let's graph all these. Four, 6, 7, 2, 4, 5, 2 and 3, 0, 1, 2, 2, 4, 7. Alrighty. That's what I got. I love seeing the makeshift straight edges. I've got a wallet, I got a cell phone, I got homework, I got snack bag. Right on, dude.